Okay, we are going to go over number 2 on our review. So the question tells us that a ball is thrown directly upward with a velocity of 64 feet per second. Its height in feet after t seconds is given by this function, h of t equals 64t minus 16t squared. What we have to do for part A is find the maximum height the ball reaches, and then for part B, at what time does this occur? If we want to find this using algebra, we can use the x equals the opposite of b over 2a, which is going to give you the x coordinate of the vertex. Okay, this is negative here. So we know that the path of the ball is going to be modeled by some parabola. And what we're trying to do is find the max value here. Okay, so the first thing I'm going to do is find my x. So the opposite of b over 2a, negative 64 over negative 32 is going to be 2. Right? So to find the maximum, all you have to do is plug this value of 2 into your original equation, and you should get 64. So the maximum height the ball reaches is going to be 64 feet, because this is measured in feet, our height. And then it says, at what time does this occur? Well, remember that t seconds, that's our input value. So your x coordinate or your t coordinate is going to be the time at which it occurs. Well, we already found that. That was 2. So after 2 seconds, the ball is going to reach its maximum height of 64 feet. So I did this by hand using algebra. You can also use the maximum function on your graphing calculator. And that would be a great way to check this. So when you do that, you will get 264 as your max value. Okay, so after 2 seconds, the ball will reach 64 feet. Okay, so we're going to go on to number 3. And this one we have to describe the end behavior using proper notation. Draw a sketch of the graph or explain how you arrived at your answer if you did not use a graph. So I did not use a graph. You can choose. You can either graph this function and draw a sketch of that, or you can explain how you found this. On your test, you're going to have y goes to blank as x goes to negative infinity, and y goes to blank as x goes to positive infinity. Remember that as x goes to negative infinity, all that means is what happens on the left side of the graph. As x goes to positive infinity, that means what happens on the right side of the graph. So when you're thinking of your graph in terms of x, okay, positive infinity is the right side, negative infinity is the left side. And then for your y, that's going to be up and down. If the end is going up, then it'll be positive infinity. If the end is going down, that will be negative infinity. So you don't even have to graph this. You can just look at your degree. If your degree, in this case our degree is 6, if it is even, sorry that's blurry, okay, if it is even like it is here, which is 6, then we know that the ends are going to go in the same direction. And then we can look at the leading coefficient. So for this one, the leading coefficient is going to be negative, which I underlined it here. Maybe I'll just draw an arrow. Okay, and that is going to be negative, which means that it's going to fall on the right. So like I said, you're going to have fill in the blank. So if you didn't write yours exactly like this for your review, that's okay. You'll have to be able to fill in the blanks here. So on the right side, we know that it's going to fall, which it will be negative infinity. Because these are the same, in both cases, you will have to make them to negative infinity. I'm sorry that is blurry. So